Bismillahirrahmanirrahim. Today I'm going to start my lecture on Formazone dyes for the color chemistry students, especially what the Formazone dyes are, how they are produced, and how they are applied in textile industry. That's the main topic that I'm going to cover today. So let me start with the Formazone dyes. It's a special class of azo dyes, I would say. It's a special class of azo dyes used in textile industry. It's pretty special class. Why it is special, I'm going to discuss it further. For the preparation of Formazone dyes, we need two things. What the two starting entities are required. Number one, we need compounds with activated carbon. Compounds with activated carbons are required for the preparation of Formazone dyes. Secondly, we need diazonium salts. So if you have a compound which carries activated carbon, that is the requirement for the preparation of Formazone dyes. Secondly, you are supposed to have diazonium salts. If you have two things available with you, you can react them together for the preparation of Formazone dyes. How those reactants do react with each other to produce the Formazone dyes, I'm to explain that aspect. And before that, I will give you a few examples of compounds with activated carbons. Compounds active carbons, what they are really. In any compound, the carbon which is connected with two withdrawing groups, the carbon which is connected with two withdrawing groups, they make this carbon acidic one, mean these protons available at the carbon, they become loosely bounded and they can be obstructed by base. So such compounds are supposed to be compounds with active carbons, activated carbons. There are very many examples. Different sort of esters have been used for this purpose. They could be of the same chemistry, same substituents, similar nature, or they could be different from each other, like this one. This will act as an active carbon because the carbon will have loosely bonded protons due to the presence of two withdrawing groups on its adjacent. So such compounds are supposed to be called as compounds with active carbons, compounds with acidic carbons. Those carbons actually become acidic due to the presence of two adjacent withdrawing groups. Secondly, we introduce actually some sort of strong base like sodium ethoxides. We introduce this sort of bases. These bases have the capacity to remove the protons from the carbon, generating negative charge at this carbon. So once we want to prepare formazone dye, we need to have this sort of a compound where we have a carbon with acidic protons, which could be removed, which could be abstracted by some sort of bases. So this type of compounds are required as a requirement number one for the formation of azo dyes. The second requirement was the availability of diazonium salts. What are the diazonium salts? It has been discussed in detail in my last lectures, Such compounds are called diazonium salts. Those are produced actually from corresponding amines. Corresponding amines could be used for the preparation of diazonium salts. Certain reagents, reaction conditions are required, which have been discussed in my previous lecture under the heading of diazonium salt preparation, diazonium as an electrophile. So one or two lectures have been delivered on this subject. You are supposed to consult those before you try to understand the preparation of formazone dyes. In fact, what we used to do, we start with primary amines like aniline. We use sodium nitrite and HCl, and we keep temperature from 0 to 5 degree. That is very important thing, Then as a result of the reaction between these entities, we generate this sort of compounds called diazonium salts. Where nitrogen carries positive charge, somebody having positive charge is supposed to act as an electrophile. So this is how the diazonium salts are produced. Once you have diazonium salts, once you have compounds with activated carbons, which have which are acidic protons, so you can react them together to produce formazone dyes. Let me move in that direction now. To make you understand, let's say we have this type of compound. Yes, we can have some sort of an ester. If we reacted with some sort of base like sodium ethoxide, we have an idea this body can abstract one of the proton, because two protons are available at that carbon. So one of the proton will be abstracted by this body. So what will be the resultant? It will look like, and this carbon is supposed to carry a negative charge, because one of the proton has been removed, taken by the base, and its electron remained with the carbon. So consequently, carbon has to carry positive charge. At this point of time, if we have sort of a diazonium salt, nitrogen carries positive and negative. We have a diazonium salt, a sort of a diazonium salt. Then what could have happened? This negative carbon will attack at the nitrogen. This negative will attack at the nitrogen, giving us sort of nitrogen, double bond nitrogen. Here is our R group. So it will look like this one. A new bond between carbon and nitrogen has been generated. One of the proton which has been removed from here has been taken by the base, and then this sodium would have reacted with chloride to form give you sodium chloride. So at this point of time, this is supposed to be the product. At this point of time, we have an idea that this carbon still carries one more proton, because in the start it carries two protons. So one was abstracted by the base, giving this sort of an entity having a negative charge at carbon, which reacted further with one of the diazonium compound to give this product. So if we put in again base, second equivalent of the base, 1 mole of the base, then base will abstract the second proton. Then what happens then? Actually, it is supposed to look like over here nitrogens, here is the R. Similarly, there will be a negative charge again. I can write negative. There is a negative charge. Now if we bring in another molecule, of diazonium salt, similarly this body, the negative charge will attack at the nitrogen which carries positive charge. So what will be the resultant? As a result, we can see that there will be a new bond between these two bodies. Then we will be able to write it like this way, Both of the protons from this carbon, which is supposed to be acidic in nature, both of the protons has been removed, has been abstracted by the base one by one, and two equivalents of diazonium salts has reacted with this carbon, giving us this sort of a product. At this point of time, what could has it happened? We have an idea the nitrogen carries lone pairs, This lone pair again could attack at this carbon to generate bond number 2. In order to satisfy the valency, at the same time the carbon will kick this as a leaving group from here. It will kick this part as a leaving group from here. So what is going to happen then? I should correct it over here, So what will happen over here? This body has been removed. I can write. So there will be a new double bond between carbon and nitrogen, and this OR has been kicked out, It has been kicked out as a negative entity from here. It has been kicked out. So at this point of time, this carbon will carry positive charge because it carries 4 bonds at the moment, 2 with the carbon, 2 with the nitrogen, So it is supposed to carry positive charge. In order to satisfy this positive charge, protons from acids are put in, Protons from acid are put in. Proton from acid, when it comes closer, this bond between nitrogen and nitrogen, which is actually exceeding the valency of the nitrogen, it will shift from nitrogen to nitrogen towards this one. It will make a bond with proton in order to neutralize this positive charge. So what is going to happen then? What's going to happen then? a bond between nitrogen and nitrogen will shift towards hydrogen, which shift towards proton. So a new bond will be look like this. We will have a bond with nitrogen. So fourth bond of the nitrogen has been removed, so it will become neutral. Its positive charge has been neutralized. So this will be the final product. This is called Formazone dye. It's a special class of dye because it carries two azo groups, diazonium salts generated from primary amines as per the previously discussed methods of the diazotizations. So this is going to be the final product. However, what has been observed, this product actually appears like ring. This is a product which actually appears like a ring when it is observed in some sort of analytical structure termination techniques. It appears to be some sort of a ring structure. How it could be? Nothing is that this proton which we write over here, it could be written on this side. There won't be an issue, Proton we written over here can be written on this side, no problems, because it has bond with the same nitrogen. Once this is shifted to this side, we have an idea about this nitrogen. It also carries lone pair, so this bond makes a sort of hydrogen bonding with this nitrogen. So this hydrogen of this nitrogen makes a hydrogen bonding with this nitrogen. So then it looks like a 6-membered ring, number 1, 2, 3, 4, 5, 6. To be very precise, people used to write like this way. They take R's towards outer sides, something like that. So it appears like a 6-membered ring. In fact, it's not a 6-membered ring because this is not a covalent bond. It's just a sort of hydrogen bonding is there. But it appears to be a sort of a 6-membered ring. So this is the final shape of the product, the Formazone dye. This R means anything. Whatever was the starting, this R does not belong to this bodies. This R actually belongs to the diazoniums, This R belongs to the diazonium salts. So whatever was the starting material for the diazonium salts, those substituent will be present over here. If we have used aniline for the preparation of diazonium salts, so we will have a ring over here, benzene ring. If you have used sulfonilic acid, or we have used anthranylic acid, or somebody has used H acid, J acid for the preparation of diazonium salts, then corresponding substituent corresponding structures will be available here, and you can get the same sort of the dye. So this is the basic idea behind the preparation of Formazone dyes. As I've told you, two things are required. Number 1, carbons with acidic protons, and number 2, we need two equivalents of diazonium salts. If you have two availability of these two things, two entities, two reactants, you can react them together as per the scheme in the presence of a strong base. You can prepare Formazone dye. Let me explain it again for you guys. We have this sort of compounds. You have an idea about such compounds. They're frequently available, and you do have idea about the reactivity patterns as well. Some sort of sodium methoxide Um, base has the ability to abstract proton over here. Once it abstracts proton, the carbon is supposed to carry the negative charge. At this point of time, if you bring in any sort of diazonium salts, as we have an idea in diazoniums, the nitrogens are supposed to carry positive charges, so those negative will react at the positive centers, giving us this sort of a compounds, producing a new bond between carbon and nitrogen. At this time, again, this carbon carries one more proton, because in the beginning it has two protons. We can bring in another sodium methoxide. It will take away this proton number 2, generating again a negative charge over here. That negative charge could attack the diazonium salts molecule number 2 in the similar fashion. So there will be an attachment of two diazonium salts with the same carbon. After that, I've told you this nitrogen, almost every nitrogen over here carries a lone pair. So the one of the nitrogen out of these two attacks to the lone pair, removes one of the substituents at the acidic carbon, generating a double bond between carbon and nitrogen. And there is also a presence of a double bond between nitrogen and nitrogen. I've just explained to you. Then at that point of time, the protons from acidic protons could react to settle down the positive charges, and that is the proton from the acid that got attached with the nitrogen, and then this proton generates a sort of hydrogen bonding with the next nitrogen's lone pair, giving a sort of a 6-membered ring. And this is the final form, final structure of the Formazone dyes. Formazone dyes are very much used in textile industry. They are of bright colors, because two two azo parts are involved here. So there is a sort of a larger area of the resonance of electron is available. So different colors, different shade could produced. Let me give you a practical example. Let's say again, we have used sodium methoxide. Similarly, we will have OR, whatever the starting material, having a negative charge. Let's say we had aniline in our lab, frequently available entity, and we reacted it with NaNO2 and HCl, keeping the temperature 0 to 5 degree. The temperature 0 to 5 degree keeps the product as diazonium salts. If the temperature raises above 5 degree, I've given a very special lecture on reactions of nucleophiles and aromatic rings. In that aspect, if the temperature of the reaction raises 5 degree, this aromatic ring will undergo a sort of a nucleophilic reaction with any other nucleophile, because due to the evolution of the nitrogen, due to the increase in temperature. So once you do diazotization, you need to control the temperature of the reaction, and it should be less than 5 degree. So it is supposed to give us diazonium salt like this, which we use over here. I can write this way, and I'm writing like this one. So it carries positive charge. As just explained, this negative will attack at this one, so there will be a bond between nitrogen and carbon. At this point of time again, if we bring in sodium ethoxide, it will abstract the proton number 2. So what is at the moment really? We have this one from the first, and then we have a diazotized salt which will react it again. Negative from here attacks at the positive, so giving us this sort of a product, So both diazonium salts got attached with the carbon, which is supposed to be acidic in nature. At this time, what happens? A lone pair of nitrogen attacks at the carbon, and then in order to keep the valency satisfied, nitrogen will kick this body out, a sort of a nucleophilic substitution, because lone pair attacks in the form of a nucleophile and the rest goes out as a form of the nucleophile. So what happens then? We will have this sort of a compounds, and then we will have nitrogen with double bond, and then nitrogen with double bond, and then here is your benzene. Again, this body will be a positive charge because it has 4 bonds, 2 with the carbon, 2 with the nitrogen. In order to neutralize at this point of time, we just put in acid. Acid's proton reacts with this bond, it will undergo neutralization. Here we will have a attachment of the proton with this nitrogen. And then in the subsequent step, what happens? This proton creates a hydrogen bonding with the lone pair of this nitrogen. So this will be the product, This will be the Formazone dye produced from the diazonium salts of aniline. You can have the diazonium salts of H acid, J acid, sulfonilic acid, and any other amine which carries sort of an aromatic ring that could be used, for the preparation of diazonium salts, and those diazonium salts could be further used for the preparation of Formazone dyes. One thing I've just explained that, let's say any sort of substituent could be here, and we can have this sort of, I've just explained, but I'm trying to convey you guys. We actually use 2 equivalents of diazonium salts. Both they could be same, or they could be different from each other. They could be different. What does it mean? Let's say in the very beginning, when we get negative charge on the carbon and we bring in diazonium salts of aniline, I've just explained to you. So it can undergo reaction over here to produce this one. So this is the settlement of the bonds. Is that fine? Then we produce next negative charge again using another mole of sodium methoxide. We produce again negative charge. Now we can bring in again another diazonium salt as we have an idea. This time we can bring diazonium salt of any other entity, like over here one can bring the diazonium salt of H acid, So similarly, it will undergo reactions over here, then the attack of the lone pair, then the removal of this body gives us sort of a double bond here, then incoming of the proton from the acid could give you this sort of cyclic product 6-membered ring. So in this dye, the diazonium salt on one side is different from the diazonium salt of the other side. So this gives you a chance to produce a variety of Formazone dyes, because as I've told you in the very beginning, for the preparation of Formazone dyes we need two things. One is compounds which carries acidic carbons, which carries acidic protons, Secondly, we want to use two equivalents of diazonium salts, diazonium compounds. Those diazonium compounds we could be used of the same chemistry. They both could be H acids, both could be diazonium salts of aniline, diazonium salt of aniline, or one can go for the option number 2. You can bring in diazonium salt of aniline once, and then the second time you can bring in diazonium salt of H acid, or you may go the other way around. You can bring in diazonium salt of H acid in the beginning, and you can bring in the diazonium salt of aniline afterwards. In next dye, you can keep the activated carbon same. You can bring diazonium salt of aniline, but this should be diazonium salt of sulfonilic acid. Again, you can go for the preparation of dye number 3. Keep this body same, diazonium salt of aniline plus diazonium salt of anthranilic acid. Again, diazonium salt of aniline, but you can bring in over here the diazonium salt of J acid, and so on and so forth. So you can produce a variety of dyes by selecting different diazonium salts in different combinations. Formazone dyes can be produced as per the requirement. The diazonium salts, they could be of the same type, they could be of different types, and you can have the compounds with the activated carbon. They are easily available, or in any of the I will try in my next lecture to explain the chemistry of those such compounds which carries acidic carbons with acidic protons, how they are produced, what is their importance, what is their use in addition to their use in the synthesis of the Formazone dye. So this is all about for the preparation of Formazone dyes. If you have any questions, you may put your question in comment area, or you may approach me through WhatsApp. I will be happy to respond at the earliest possible, inshallah. Thank you very much. I hope you got better idea what are the Formazone dye. Please try to find some relevant example from the literature just to get more knowledge about this fascinating class of dyes. Thank you very much. Assalamu alaikum.